root at VIT GPU. Now this is what the admin. So myself, Ilango sir, Balasundaram sir, and a couple of Saranan sir, and around 5 or 6 of us have admin rights for our GPU. So because the entire GPU we can leverage. So in the GPU we have this command. This command says that the complete. This is the. Just let me show you. So this is our Nvidia -SMI. When I do this command, it will show me the complete H100 architecture. So you can see that Nvidia H100 PCI, peripheral component interconnected extended. So 29 degrees Celsius. Now actually it is running in our data center. So in the morning it was running with 26 degree, but now it is 29 degrees Celsius. All of you can see in Dockers also, when we give inside the Docker also you can all see. And the total power watts is around 350 watts. Now 50 watts is consuming now. And 48 watts is consuming the second. We have two devices. Actually, two devices not working separately. They are in tandem, coupled together to work it as one powerful beast. So it is like two people push the tug of war. So 5 or 6 people push it, right? The same way, 2 H100 is giving you the powerful beast. So in industry, they use 10,000 H100s, 50,000 H100s. That's how industry they do. We go for two things. That's what we purchase around 1 crore. And in the right hand side, you can see 80 GB RAM on the device 1, and device 0 80 GB, device 1 80 GB. So totally among 80 GB, so initially only 3 MB is used now because nobody is using it now. And the other thing is the percentage utilization is 0% now. Okay. Now none of the processes are running it here now, because only when you take huge number of processes, the GPU will be occupied completely. So that way you can able to understand how my Nvidia is working. So all of you, when you get a Docker, you can able to run this command. First command is Nvidia -SMI. So using this, you can able to run it. Now we are going to create Dockers on it. So I already created 2 Dockers. The first Docker I created 3 hours ago. In the morning when I created, the name of the Docker I created is Pradeep_GPU. You can see the right hand side. And next one is Pradeep_only CPU. So I just show you a demonstration of only in GPU how it runs, only with the CPU how it runs. So I'll show you both. Okay. Now let me show you the CPUs, number of CPUs, cat rock CPU info. So when I use this command, you can see the number of cores is 95. That means 0 to 95. So totally we are using 96 cores, 96 core CPU. So GPU is 114 compute unit GPU. So maybe I'll just show you that also. LS topo. Okay, it's not. So LS topo. So here it is 90. You can see that 95 CPUs, and we are using 114 compute units in H100 in one device, 114 compute units. So 2 device means totally 228 compute units we have. So when you purchase in Google Colab, when you purchase for 1,000 rupees per month, there is one package. They give some GPUs, compute units. They give 100 compute units, which is not as powerful as H100. They give 100 compute units. Most of your job will be solved. But here we have this 114 compute units. It was very powerful than Colab. But I could not able to compare the result of Google GPU along with H100. I could not able to compare because Google doesn't give the complete data on what kind of GPU they are allocating to us. But they are giving 100 compute units. What we have is 228 compute units. So that means 228 processes along with the 96 CPU cores, we can able to run the models. Okay, right. So now this is one. First thing I do, just go into my own Docker. Let me go with the Docker exec -it Pradeep_only CPU. I will go with only CPU first. Later on I will go into it and /bin bash. Now these things you need not bother because I am just giving a demo there. So when we send you the credentials, like earlier when Ilango sir sends the credentials, he send you the credential username and password with the URL. So I mean the secure shell. So you can log in it, go to the terminal, you can use it. But what I am using now is from the admin part of it, I am just doing it. But in your case, you will get one SSH username and password. You can use that. You can use whatever I just use the commands. Okay. Now, Okay. Now I am into my own Docker. You can see that I am into my own Docker. So this is my Docker ID. So this ID I just log into it. Now when I see Nvidia -SMI, it will say no command not found. Reason being, I just logged into a CPU only model. So now GPU is not enabled in the Dockers. Because some people say that I don't want GPUs, I just want a powerful CPUs. So we give 96 CPU, we can use that. But the purpose of AI, ML, deep learning, all these models is we use a GPU for most of our tasks. Okay. Now I am going to show you one demonstration only on CPUs. Okay. Now what do I do is I'll go and create one source code. Anyway, I don't want to write any source code now. I'll just generate a source code in front of you. Okay, so give me a PyTorch code for CNN network uses fashion MNIST dataset with configurable hyperparameters, 2 convolution layers, let me say 3 convolution layers, 2 max pooling layers, and 2 fully connected layers. The code should print the training time also. So as you know that PyTorch is one kind of code, because I am very fond of using PyTorch, but we have another option, Keras is there, and we have Scikit is there, and we have TensorFlow there. But some days I just PyTorch was comfortable for me, but it's up to you what language you want, you can use that. Now let me get it from. So you know that Grok is one thing, now it is there in the top thing, whether you take accuracy, prediction, and all the parameters, the Grok is there in the top. It is by Elon Musk. So he defined this, because I never used ChatGPT for the past, after Grok is launched, I never used that, because in accuracy point of view, it is perfect, prediction it is perfect. And so anyway, just configurable means we have the configurable, the hyperparameters also here. So you can simply change the values here so that you can generate the complete coding. And finally, we can able to get the training time. So training time is what we wanted, because for the seeing the performance of it. Okay, so yeah, training time is there. So I just copy this code. Now first thing is, let me go into my this only model. Now generally when you see pip install something, if I do, it gives you some error like this, externally managed environment. You will usually you will get one error like this. Please make a note of this whenever you get this error, because all of you will get this error if you are using Ubuntu operating system. If you take any other Linux modules, you won't get this error. For that, there is a small workaround they have given there itself. What we do is Python 3-m virtual environment. We have to create one VNV, virtual environment, and create one folder here. I create one folder called as my environment. Already I just created it. Now this is my environment. Here I just use source dot myenv bin activate. So once I do the activation, now you can see that the terminal changes to my environment. So inside this environment, I can download, pull all the softwares. So I already installed the Torch, the PyTorch modules, everything I already installed it. Anyway, I'll just show you the command Torch, Torch Vision, Torch Audio. Okay, these 3 commands. Sorry, pip install. So see that I already installed this, but I am going to install the same thing in a GPU only model. I am going only for the CPU only model. Okay, so I just installed everything here. Now I am just open one file, nano fashion.py. I just create the file name called as fashion.py. In this, I copied the code, paste it. So this is the code which I pasted from the Grok engine. Okay. Now save this file. Now my command is to simply run it, Python 3 fashion.py. Oh, how many? Anyway, I didn't check it how many epochs it was running. So now it is downloading the dataset, because in with fashion MNIST dataset, CIFAR and MNIST, it comes directly as an API. So you can directly download it. Now everything downloaded. Now see that epoch 1 of 10. So now first epoch is totally 10 epochs are running. So you know what is an epoch. So epoch means, suppose for example, if you are going from Chennai to your house in the bus in the evening, in the left hand side you count the number of trees, whatever you see from Chennai, your campus to your house. You count the number of trees. Okay, so that is 1 epoch. You visited 1 epoch. Second epoch means again tomorrow, again one more time you go for it, you count the number of trees. So first day you get 238 trees. Second day you may get 235 trees because you missed 4 trees. Then third day you go, fourth day you go, fifth day. Like the 10 days when you go it, then the 10th day you feel that, oh, I counted, it is only 237. That means 10 days I have counted. That's what the number of epochs. The entire data set is traversed from the beginning to, so if you have 10,000 images, all the 10,000 images will be traversed. That's what epoch means. So now still it is going on. Anyway, I will just, for your time thing, I will just reduce it to 5 epochs. Or let's say 3 epochs. Let me take 3 epochs. I will give the exercise to you, you can try that. So 3 epochs, I will just use it. Yeah. So now it won't download again because already it's downloaded. It directly go into the number of epochs. Yes, 1 of 3 now. Now this is running only on a CPU. I will show you the same thing on a GPU also. Now in the meantime, in the GPU also, I will just, okay, here the same terminal will go, okay. So 100 steps for 1 epoch totally, and now it is epoch number 2. So it takes some time. But here one provision here is you can able to run all these algorithms only with you are staying in the campus. As of now, we don't have any external access for this server. We are given only thing. So training time, if you take totally 53 seconds. So what do I do is I'll just take this. Accuracy, don't bother about it. Let me take only the training time 53.01. So here I will take CPU only 53.01 seconds. So this is my training time. Now, so this is my, it handles only with the GPU. Now you can check one more coding, that PyTorch code for CUDA, CPU and MPL, MPS. Okay, now this is one code. Oh, sorry. PyTorch code for CUDA, MPS and CPU. Okay, simple logic. Okay, fine. So this I will just copy, and when I use one more file, nano CPU checking, CPU checking.py, and paste it. Python 3 CPU checking. Now you can see it tells that running on CPU, because this is the code to check whether I want using a CUDA or I am using a CPU or MPS. MPS, many people, some of you have a MacBook with you. Even I am also having a MacBook, but my MacBook doesn't have a GPU because it is a Intel Mac. Intel Mac means before M1, M2 they have Intel Macs, but M1, M2 they have GPUs also. If you take a M4, recently there's a M4 came, M4 just last week it was launched. M4 have 10 core GPU. So for some model they give 10 core. 10 core GPU is almost as powerful as 3050 of Nvidia. So Nvidia, when you have a 3050, similar performance you can give it. But MacBook uses a different thing called as MPS, Metal Performance Shaders. So if you are using your MacBook for deep learning algorithms, your MacBook by default has a GPU. Unless you are using Intel Mac, you have a GPU. That GPU can be configured for 3050. Because I heard that in one faculty from other school, he asked that he already have a MacBook of M2 and he wanted to purchase one more Nvidia based desktop machine. He asked for a suggestion. I said, sir, you already have a M2. You use MPS to schedule your deep learning algorithm, because M2 is somehow lesser, but it is a GPU running in their own machine. After that, you understand that okay, there is a GPU inside their machine. So some people are purchasing MacBook without knowing that it is having some 10 core GPU. 10 core means it has some 10 compute units of it. Okay. So now I am running on a CPU. Now it says CPU tensors are on device CPU. So now this is what we have done it. Now let me close this window here. Exit. So my job on a Crore machine is done. Now what I do is I just log into one more of my Docker is I have one other thing called as Pradeep_GPU. I am just running this thing now. For this thing, docker exec -it pradeep underscore gpu, then bin bash. So now I am inside my GPU machine, Nvidia underscore SMI. You can see this command is enabled now. So you can see this command what I have shown you there. This is how the way you can able to see. Sorry. So you can see all the performance of the CPU, everything you can able to see in this machine. So now we are using a GPU now. Now what I do is the same code what I copied here. Now this code what I have done here, copy. Okay, so this code, but this code have some things here. Again, I am just using Python 3. Okay, now I need to install everything from the beginning. So Python 3, it is not there. So first thing, this is how the way empty we will give. This is how the way you will be given a terminal. So first what I do is, first I use apt update. So first command is apt. Anyway, I'm just recording the complete video. I'll share the video after I put it. Okay. Now after that, apt install python 3 -full python 3 -pip. See, for running mainly on the deep learning models and machine learning, this whatever I am using the commands for PyTorch, it's fine. But if you are using TensorFlow, the corresponding commands you can please install. Okay, now I am just installing Python 3 full package of Python 3, including development libraries, all these things, and pip also I am just using pip. So I am just installing it now. Now I am just doing on a GPU now. Okay, so it's only downloading time. So once you download it, then you can able to use it. That's why in the CPU I already downloaded. In the GPU I wanted to show you how we can able to install, how long it takes. So not more than 1 hour. So for running your model. Anyway, only for writing the source code you will have, but source code also is generated using some AI models. Okay, now this is only one package what we download, but after that we have to install the Jupyter notebook if you want, or Torch, everything we have to install. Now it will be asking you what geographic location you want to use. So I am using number 5 is for Asia and number 44 for Kolkata. Our time zone is there? Yeah, I think 44 Kolkata is there. 44. Okay. Now actually this is important sometimes. See, some models what happens is when we have a different time zone and our system timing is different, sometimes some model misbehaves. Okay, that's why I always prefer to have a common time zone, our Asia Kolkata. So that way you can able to use that. Okay. So now this thing is done. So now what I do is, again I am going for a virtual environment, Python 3 -m venv, and I am using my own folder called as my env. So just now I am creating now, because this GPU model I am doing everything in front of you, so that the same commands you can follow. Then source.myenv bin activate. Now you can see in front of my login here, this is activated. Now I am using pip install torch vision, torch audio. In case if you want to have notebook, you can use notebook also. So you download some packages. Okay, now we download. So in the meantime, I will go to the Google Colab and then I will run the same things in Google Colab. Okay. So here, this code what I got generated the previous thing. So copy. I just go into Google Colab. Already I just created Google Colab. So in Google Colab, you might be knowing that many of you might have done this. Change runtime type. When you change the runtime type here, it will give 3 options freely: CPU, T4 GPU, and V2-8 TPU. So tensor processing unit, GPU and CPU. Now first time I am going for a CPU. So now running it under a CPU, I am pasting this and I am giving you, not this. Not this code. Yeah, fashion, yes. first code I will take. Here I will come here and then I paste it. Now only thing is I use 3 epochs and I am running it here. Okay, so first time it downloads, because in my login I already downloaded PyTorch, so there is no need of, else you have to download PyTorch also here. PIP install Torch Vision Torch Audio. Now let me check it there. Yes, it is downloaded. So it's for some time it take download. That's why in one of the machine I downloaded, other machine I just wanted to see how it is been downloaded, all the 3. Yeah, so now in our Google Colab it is running now. Yes, it is downloaded. Now it will go for the epochs. Yes, okay, now it's going on. Now think of the timing now. Epoch 1 of 3, it is waiting for how long? But in the previous case, we have gone second and third. Anyway, let it run because it takes some time. In the meantime, if our thing is completed, we will go on a GPU now. So both, let it run both parallelly. Yeah, I think it takes more amount of time. Anyway, let it. Because I given 3 convolution layers and 2 max pooling layers and 2 fully connected layers. So number of the neuron operations is very high. So probably anyway, we'll see on a GPU. Our purpose is mainly on the H100 GPUs, how fast it is running. So in my machine, in the meantime, I have my own machine also. So the machine which is running in my room, nano fashion.py. Okay, now I remove it, rm fashion.py. Let me run in my own machine also. Okay, so here I will just change it to 3 epochs. Oh, sorry, Python 3, sorry, source my env bin activate. Okay, so now in my machine also I just made it run on all the 3 machines. And see, already it's downloaded, so that's why. So my machine, you can see it is having a 12 core CPU. In my room I have a desktop, it's a 12 core CPU. I thought my machine is not a powerful beast, but only when I run this algorithm I thought that my machine is so powerful, even my CPUs are powerful. See, yeah, our Google is still struggling, Google Colab is struggling. Now still first epoch is not yet over, and my machine almost is completing the first epoch. Okay, let me go into our thing. Okay, now it is downloading, Torch is downloading, because everything will complete in just 1 hour. So that's what my thing is. I don't write the code, I just only configure some parameters, some settings, and then I make it run on a GPU and then check how it is running on a GPU. Okay, so I think it's over, I suppose. Let's see. Yeah, I think it's done. Yes, it's over. Okay, so in my machine it took around 88.79 seconds. So here I'll write it here. Number 6 is my machine. So 88.79 seconds. Still our Colab is going on. Okay, and so now it got installed. So now what I do is I'll just open the file, nano CPU checking.py. So nano is not there. So nothing will be there when we give the Docker to you. You have to install everything. and apt install. Nano is one kind of editor. So either you can use VI or gedit. Gedit is a GUI based. Nano is a terminal based editor. You can able to use it easily. So Nano CPU checking. So now I'll come back here. Yeah, I'll just here. I just okay. So this code I'll just copy, and I'll just copy it here, paste. So Control X, Y, and Python 3 CPU checking. Okay, now you can see that this is where our GPU machine. So running on CUDA GPU, Nvidia H100 PCIe, and input tensor X. What is the tensor value? Because it's some random numbers, and CUDA 0, it is running on CUDA 0. So we have two units, CUDA 0 and CUDA 1. But now for running this, just in one CUDA GPU itself, it is completely running. So tensors are on device CUDA number 0. So we have two devices, CUDA 0 and CUDA 1. So that also you can able to use it. Okay, now I am running our file called as fashion.py. So now I'll just go back here, and I'll just copy this. Sorry, not this. Copy and paste. So only thing is I need to change the number of epochs as 3. Control X, Y. So Python 3 fashion.py. So will fast agakudadu, not this much fast. See the power of GPUs. 17 seconds. Okay, so but the complexity involves here is I used 3 convolution layer, but when I tested in my room, I used 2 C and 2 convolution layer, 1 max pooling layer, and 1 fully connected layer. Further, it took 7.38 seconds. Now it takes just 17 seconds to do this process. Maybe run one more time. Anyway, same thing. So 18 seconds approximately. So I'll just put it here, H100 GPU, 18 seconds. 18 seconds, and still our Google got over. Still, see, Google CPUs are still running. Some of our students are using Google CPUs for running such a complicated models. Okay, now you understand that how you used it. Okay, because we used a 96 core CPU. When you were running the Docker's previous time, actually it was running on the CPUs, but you are comfortable in using the CPUs. And because 96 core CPU do always fast compared to your 8 cores in your laptop or a 12 core in your laptop, it compares it fast only. But GPUs are very powerful. Actually, when you see that, it's almost you can see H100 CPU alone, it's 1/3 faster. Okay, and in my machine, what I run in my room is 88 seconds. But anyway, this it's a shock to me. During this process only, during this configuring this process only, I understand that the machine what in my have in my room is a powerful machine. Okay, and those machines mainly in the electronics department, those computers, desktops. So from that only they gave one during when I asked the CTS, I mean some time ago. So that's what here. And Google CPU still it is running and not yet done. So anyway, it might be more than 5 minutes or so. So this is what I thought of showing you. But anyway, I'll just give the source code. I'll give all the information you can able to run during your free time. And this H100 actually when I initially when I told the H100s are very powerful beast, and it's a good experience that even in some of one of my friend he's working in Woosung University, South Korea. So when I just talked to him, when he was like, hey, what, you have a 2 H100s? That's what he just in their particular in South Korea, China, and those places, having worked on this H100s GPUs for modeling you'll have a greater impact on publications and greater chance of selecting also in publications. So that's why this H100 is something which we cannot afford as an individual, we cannot afford, but which is available at our discretion. So maybe our Dean sir will tell you more about in what case you can request. So actually we got totally 38 requests in the second round of information. So all the previous Dockers we have deleted. So I'll just show you that also. So we have deleted all the previous Dockers. Anyway, it's not okay. So only these are the Dockers 5 days ago, and we have just started everything 5 days ago. And most of these things I just stopped it. So excited means we have already stopped it, and currently running is this GPU is running now currently. Okay. Now this doesn't take much space. Actually, myself and Dean sir, we went to IIT Ropar last February. We went for one project. There was one professor called Sudarshan Iyengar. So he is a professor working there, and he usually take NPTEL courses on artificial intelligence, other thing. And I asked simply, sir, do you have any data center in IIT Ropar? Madras, IIT Madras, they are having a very big data center, I know that. I have visited also, but IIT Ropar, they said, yes sir, he literally told this word, we are expecting. That means over and above the models what is running in their data centers, it's very huge, and the heat what is generated is very huge. They don't have a sufficient cooling system. They have a sufficient cooling system, but on the cooling system they don't patala. It is not sufficient to handle that much amount of cooling capacity to the GPUs there. That's what they are telling, that every other minute or second the GPUs are running. So that's why they are telling we are waiting for that. So such kind of data loads, data sets, they are just training. But Nvidia GPU la, when we started working, and before 10 days before, when I happened to see inside it, out of 80 GB, only 16 GB was occupied. 16 GB was occupied in the CUDA 0. We have two CUDAs, one CUDA 0 and CUDA 1. In CUDA 0, it was 16 GB occupied out of 80 GB, and two processes were running in the GPU, and it was literally not used. So our job is to make as many models to run as possible to make that particular system very a heated system. So that is what the purpose of it. But anyway, now I will just show you how much temperature is now running. Now you just see what was the initial temperature when I started, 29. Now kudutha oru model ke it is taking 1 degree extra. It's slightly increasing 1 degree. But in the morning when I came, I think yesterday also when Ilango sir and myself we checked, it was 26 and 27 degree. So now it is increasing to 30 degree. And 50 watts, the power occupation also 50 watts. But please understand, the full load is 350 watts. So if you can able to see, we have clocked 300 watts in the GPU means, then that is what the full utilization of the GPU. So if for 300 faculty members, if you run this to make it 300 watts on the first core and the second CUDA and 300 or 200 watts, that means many of us are using the GPUs to our discretion. Okay, so let me see in the final moment. So here it is 536 seconds here. So Google Colab CPU alone is 536. Let me write it here. 536 seconds. Now anyway, I don't want to go into that, but anyway, I'll just show you how it can possible. So change runtime and change it to T4 GPU. Now when you T4 GPU, when you run it and save it, now one more time the data will be downloaded. Anyway, no issues. At least let's see if this is fast or not. So it downloads the data again. When you change the runtime, the data will be downloaded again in Google Colab. But the TPU is very slow compared to CPU. Anyway, I don't want to go into the TPU part of it. So let me run only on the GPU, then we'll conclude. Okay, so now this data is being downloaded. And many of you might be knowing about this Kaggle, Kaggle. So many of you might be knowing about this Kaggle. So this is one perfect machine now available. So you need not download the data set again by downloading, converting into zip file and uploading it to there. Actually, they have one APIs now, import Kaggle. They have one Python API, import Kaggle. From Kaggle, you can able to import the dataset directly through your source code itself. And one more thing is there now in the market called as Hugging Face. Now this is what one thing which is overtaking Kaggle now, Hugging Face. So when you go for Hugging Face, it has models, it has datasets, it has libraries. There are so many things powerful than this Kaggle. So now this is what Hugging Face also have their own API calls. You can directly use inside your PyTorch or TensorFlow code inside, and directly you can make use of that. So in this case, you need not download the dataset directly and then use it in the, put in some folder. Again, uploading you have to take some time, you have to do that. Instead, you can use directly through the API calls. Okay, so this way you can able to use Hugging Face on that. Okay, so anyway, just this thing. Yeah, now it is 51.54 seconds. Not bad, it's good. 51.54 seconds. Okay, anyway, this TPU I just leave it to you, and these are the 3-4 things what you have done it. That's all, friends. So if you have any queries or anything, you can please let me know. They'll stop the